Hello, everybody. Welcome to Ashton College's live online info session for our robotics and circuits and robotics course. I'm Matthew. I'll be your host. We're joined by our instructor Sai and Rika at the moment, who is going to make sure that everything works while we're doing this webinar. Nothing breaks, anything like that. We might also be joined by Maggie from our admissions staff today, but we'll see. All right. So, Sai, how are we doing?
Hi, I'm doing great. How are you guys doing?
Doing lovely. It's so nice to have you here today.
Thank you.
Oh,
Pleasure is mine.
shucks. Now, to get things started, could you talk with us a little bit about your experience, your educational background, and what's brought you to teaching?
Yeah, definitely. My full name is Sai Nalluri. I'm a mechanical engineer by background. I did my bachelor's in mechanical engineering in a well-known university back in India. Starting then, I started my interest into robotics and I got into mechatronics. Since then, I've been working with various companies in defense, educational sector, industrial automation, and manufacturing. So while doing that, I have been a part of the Learning Academy for my company, which I worked, which was helping engineering students to develop robotics projects. They're training engineering students and to develop robotics projects. And I fell in love with it. I fell in love to bring up the next generation with the most advanced technology. And since then, I've been involved with various institutes training thousands of students in advanced technologies of robotics and automation. In order to pursue industrial automation and I want to learn more in machine I came here to Canada to pursue my master's in Western University of Western Ontario. I did my master's in automation and systems engineering, and now again I started working with food industry, farming industry, automobile industries in helping them develop more automation to make their machines more efficient. But still my mind still clings in educational sector, and I love being in this field helping the next future to nurture.
Oh, that is awesome. And honestly, sounds like you managed to do a little bit of everything, touched a little bit of everything, got a sense of how it works for in a lot of different places. And yeah,
Yes, I did.
Western, familiar with it from Guelph originally myself. All right. So, just so we have some context, what are we talking about when we're saying circuits and robotics? Is this like a more advanced area in the field of robotics? Because we do like an introductory class, but I feel like this is the next step.
Yes, exactly. Circuits and robotics is a bit of advanced level of introduction to robotics session. This gives students more exposure into IoT, more exposure into algorithm development and troubleshooting and analyzing circuits. So when you say robotics, robotics is a combination of four basic fields: mechanical engineering, electrical, electronics, and computer science. So these four fields combinedly form the core of robotics. Whereas introduction to robotics, you get the basics of programming and understanding how the robotics machines and like various devices work. This course gives you an advanced learning on what are the things that you can do with the help of robotics, how IoT works, how web pages work, how industrial automation works, and how to troubleshoot and figure out the problems in robotic systems. When it comes to understanding it, it tells you how do you find out if there is any flaw or how to improve a process.
Okay, right on. Yeah, and definitely like I can see the sort of like break and progression here. Like once we've shown you what a robot actually is, now we see like how to the like sort of building blocks for like the stuff. Obviously, you won't be able to build like anything like I'm not saying yet you won't necessarily be able to build like, but you will be able to build something with a little bit more robustness, a little bit more focus, a little bit more to it after this.
Yes, they definitely are going to build it. The only
Yeah.
difference is they're not going to build it in an industrial level,
Yeah,
a
that's what I
big
was
one, but they're
talking
going to
about.
build
Yep.
robust projects and a prototype level, a
Mhm.
small, a similar for working fashion, but it's just shrinked up in terms of complexity and size. That's it. Other than that, the performance and the applications would be exactly the same throughout the process.
Okay, so who's going to benefit the most by taking this course?
So I would say this course is a very good start to the students who just graduated out of their college or university and are looking to get the skills necessary to enter the industry, automation industry, electrical industry, mechanical industry, and also for the people who are currently in the field, uh, who are wanted to learn some advanced terminology and advanced technology that is currently running in robotics. I've seen many people who are currently in electrical field and mechanical field, but they want to come into automation because that is the next big thing that's happening currently, especially in the American states. So I'd say the students who just graduated and the employees who are currently in the field are the ones who are planning to switch the field. This would be a very good start for them.
Yeah, I can definitely see it where, like, if you haven't had your chance to dip your toes in the water yet, but you're coming from somewhere where, like, you've got a lot of it are ready or prepared to, like, hop in, great spot for you. All right. So, talking a little bit about the course outlines, it's mentioned that students will be doing some prototyping. What does that look like?
Yeah, so this course is structured into different sections. At the end of each section, students have a major project, and at the end of they have a minor project, and at the end of a course they have a major project. So throughout this course, for example, when we are going through sensors and motors chapter, at the end of the course they'll be doing a small project like home automation, where whenever a person comes inside the house, the sensors trigger the input, they write a program to turn on the fans, lights, and open the doors of a house. So starting from there, they'll be upgrading themselves with each step, and further they'll be going to IoT, where they'll be designing a web page to where you can press a button on your mobile, on your tablet, on your laptop, from anywhere in the house to turn on the lights, fans, microwaves, whichever electrical gadgets that they have. So we'll be doing a minor projects of all of these bit by bit, and we'll combine all of these together to make their own custom major projects at the end of the course.
Okay, right on, right on. All right, and obviously it sounds like there's a lot of great little project work. I like that. It's like it's very much a we take on something and like it runs through the whole thing. You've done this, now you do this, now you do this, and then boom, you put it all together. So the other thing that our course outline description talks about is students are going to be able to build and decode circuits for any process automation. Can you tell us a bit more about that?
Yes. The reason for this course being a bit into electrical, a bit more concentrated in electrical side is with the boom in industrial automation, with the government, Canadian government funding so many companies uh, to to add automation to their existing factory production line, there are a lot of jobs that are coming up for electrical engineers, automation engineers, robotics technicians, robotics operators. So with this coming in, the key skill to have to be eligible for these jobs is electrical troubleshooting, because that is a main course, because that is the core for any computer or a robot to run. So when a computer or a robot goes into faulty, there needs to be a person who understands how the mechanism on the back end of that robot works, and he should understand where is this machine going wrong. Is it going wrong on the sensor side? Is it going wrong on the motor side? Is it going wrong on the mechanical assembly side? Or is there anything wrong with the program itself? So this this skill will get you eligible to various jobs that I mentioned before, and is also very important for anyone who wants to develop their own robot. So when you're trying to develop a robot, it is It is not like a word pad where you can type everything. You will face a lot of complexities. You'll finish a robot, you'll program it, and then you press the button and the robot doesn't work, because there are a lot of factors that come into picture, and you should be able to analyze where things are going wrong, how to trace it, and how to make it better. That is one of the key skill that students take away from this course.
Okay, yeah, and no, honestly, I would have never considered like how much electrical troubleshooting needs to be a big component, but like that makes a lot of sense hearing you talk about it, and definitely like getting code to run right is hard enough, let alone making it have where it should execute right and then nothing happens. That's probably induced more than one panic attack in our lifetimes.
Oh, it does, and it also gets very exciting to
Yeah,
do that.
I can imagine. So what do you think students are going to like the most about this course?
um, the best thing is the amount of effort that we put in to this course to design it in such a way that students with a minimal or no experience can start at a very basic level, and based on their own interest they can get it to a level that they want it to. So this course is not structured in a regular way where every student goes through a similar procedure. It is, the more the student wants from this course, the more he can take it. The projects are designed in such a way that they can choose the complexity of their course, their project. If they want to choose more complex project, they will get more learning out of it. If they want to choose a medium complexity, then they can complete the course and they can get a good understanding of what's happening. That is a flexibility that this course with Ashton College is giving, which I think is really impossible to get at another place.
Yeah, all right. Definitely pulling back the curtain for some of the stuff I'm gonna ask you down the line there. But obviously it sounds like this is a really engaging course. Is there a portion that you're looking forward to teaching the most?
Yes, the one thing that I'm really looking forward are the major projects for each students. They always tend to amaze me with their unique projects where, because this course, unlike any others, is not a theoretical course. It is a full-on practical course where there is 80 to 90% practicals, and there is only 10% of theory, like just theory involved in it. So theory always goes on along with the practicals in this course, and because of this the students tend to be more inclined towards innovativeness, and at the end of their major project, when we give them ask them to choose their own projects, they come up with various problems that we are facing in the real world, and they come up with solutions to tackle that problem with the help of robotics. So the end of the course is always the best part, where you can see the fruits of your 3 months of learning.
Yeah, definitely. Oh, definitely. No, it's like always cool when you get to see like basically like if it's that much practicum, it's not like turn up your textbook and sit down. Okay, here's how you actually build the thing. So what are your expectations? Oh, I'm jumping ahead a little bit. Can you talk a little bit about your teaching style?
Sure. As mentioned, like the course is designed based on my teaching style. I hate theory. So I'm not a person who likes to sit on the book, read, and just understand it. I'd like to test that principle right away. That is the way in which it engages me. And I felt that that engages the students also very well. If I tell you that, hey, the current is flowing through your house, it is going into the light and the light is turning on, it is just a theoretical concept. But if I give you a battery, if I give you a light, and I ask you to make the connection, you make the connection like, hey, my light is not turning on. Then you understand that the light only turns on when you connect it in one polarity. If you flip it around, it will not turn on, because current has positives and negatives. You need to take care of it. There are, in order to make them understand the concepts of polarities and the flow of current, it is better to just give them a battery and light and ask them, turn on the light. And then, in that way student makes mistakes and they learn through it. That gets embedded into your memory, and that will stay with you within your memory for a long time. So my way of teaching is experiment and testing, always.
Okay, no, that sounds really good. All right. So, experiment testing, like a lot of fun. What are your expectations of students enroll in the course? How much time are they going to be spending on things outside of class? Obviously, you're talking a lot of practical stuff more than theory, so I think that changes like how much reading I should expect to do if I'm a student. But
So there is no prior knowledge based requirement for this course, and you don't have to be in the electrical or robotics field in order to get started with this course, because we're going to start, as mentioned, this course starts from a very basic level where anyone who's just enthusiastic enough to learn robotics can just jump into the session, and they can start understanding how the things that are currently existing around them, first they'll start to understand how that will work, and from then on they can take it to whichever level they want. So there is no, I'm not expecting the students that I get to have any prior knowledge. If they have it, it's good. And they can take it to whichever level that they wanted it to. But it's a very easy course. And as I've seen from couple of courses, couple of questions that are posted, you do not need any admission requirements, and you do not need to be familiar with the equipment that you're going to need to get in order to get this session going. At the start of the session, we're going to give you a run through on what are the components that we have, and we're going to teach you how to work with a couple of them, and then it's up to you to figure out how to work with the rest of them. So the course will give you the basic structure to understand the fundamentals, and from then there will be extra sensors, extra motors, and extra tech involved in your kit that you can use for your self experimentation. So the kit is very simple, very user friendly, and the course, I believe that the students are going to love it.
yeah, I can definitely imagine. Like, it sounds like this is actually just a really fun time to show up and learn and do and try. And like, obviously, you're going to get a little bit more of it if you're putting a little more into it, sounds like. But like, if you're doing something, you're going to get something.
Definitely, the more you do here, the more you get.
Okay.
That's how it is structured.
Yeah. So, obviously, you talked a little bit about this, but and you've mentioned some of the people that might want to like move from an adjacent field to this, but what types of opportunities are available for like what types of jobs and the like are available for students or people who like specialize in circuits and robotics?
So the first, as mentioned, because of this industrial boom in automation and the government funding, that the government, I've seen that it is recently funding the farming industry, automobile industry to improve automation in their existing process. It is creating a lot of jobs in the fields of robotics technician, controls technician, robotics engineer, mechatronics process engineer, embedded programmer, Python programmer, and IoT developer, software developer, and there are further fields that are involved purely in electrical troubleshooting and mechanical troubleshooting, maintenance, millwrights. Number of jobs that are coming up in the next 1 2 years, and these are the roles that are going to pop up more in the job search fields. So students or employees who are currently in an electrician field, in a mechanical field, want to get into automation technician, controls technician, robotics technician, integrators, this will be a very good choice. Students who just graduated from mechanical, electrical, computer science engineer, who wants to become mechatronics developers, project design engineers, or uh, people who wants to get into programming, the ones who wants to go into Python, embedded programmer, or systems integrator, this will be a very good choice. And these are the opportunities that you're going to see in the near future popping more up. So that's the market, and people who are ready to grab it, this is the course that you need to grab first.
Yeah, definitely. And then, what are your thoughts about like some of the long-term outlooks on the labor market, current demand? Obviously, we're seeing a funding boom. Like, what do you think the next steps are going to be?
So I seen that the companies already started automating their existing lines. So currently they are hiring external vendors from Europe, from UK, from Germany to build some automation equipment in their facility. Since that is happening, there the companies that are currently embedding this foreign technology, they need some people to take care of these automated machines. For example, now there is a farming industry that got some equipment that, you know, does vertical farming. They cut the crops and then grow it artificially, and then they make salads and stuff like that. Now they need a person who is in the country, in the facility, who needs to monitor these machines and see what are these machines doing. If any machine doesn't work, they want someone to promptly respond to it so that their production keeps on running. If not, they cannot wait for someone from UK or Germany or some other place to come and help them fix the machine right away. That will cause them hundreds of hours of production loss. So they need technicians and engineers on field to make the equipment running, keep the process flowing, and most importantly, make upgrades to the existing field. The companies, once they have the tech ready, once the process is going, they realize that, hey, this process is getting more labor intended. We need to upgrade this process in order to work along with everything else so that everything goes in a single flow. So there are being some jobs taken out of the regular industrial labor market, but there are a lot more jobs that are being introduced into the automation, robotics, and electrical mechanical technician roles.
Yeah, basically like sort of a shift I'm hearing, like away from like having a human do it, get the robot do it, but then who fixes the robot?
Yes, it just improves the production. Now,
Yeah.
the person's doing the same work that he used to do before, but the robot is doing the manual labor and the person is helping the robot if it gets stuck, which tremendously improves the production of any facility. That is the reason many companies are very much inclined to automating their lines.
Yeah. All right. And definitely very cool. So, next question I got for you. How would someone integrate what they've learned from this course into other areas and fields? Again, I feel like this is a question that we sort of answered bits and pieces of, but how about we collected?
Yeah, as mentioned, through this course, the students will learn the basics of mechanical designing a little bit, electrical troubleshooting, electrical circuit analysis, a lot of it, programming, and IoT, a lot of it. So it's mostly concentrated in electrical, electronics, communications, IoT, and embedded programming. So through this course, students will get an idea of how a product process works, the process flow of an entire product development. They'll understand all the phases that a product needs to go through in order to complete and come out as a product. So that's the project and the product has huge difference, and they'll understand all the steps that it needs to grow through: mechanical, electrical, electronics, and computer science. So even if a student who's not you know he doesn't have a specific idea of which field he's more interested into, by the end of this course he will have an idea of what a mechanical engineer does in a facility, what does an electrical engineer does, what does a communications engineer does, what does an IT professional or a computer engineer does. And throughout the process, when he's doing his own projects, most of the people realize that, hey, I like doing programming a lot. But whereas this programming is different from a regular computer science programming, this is embedded programming where you program to make things run in front of you instead of seeing the output on a computer screen. So most people like this more fascinating and they tend to move into programming field after the end of this course. And some people after the end of this course, they're more into electrical troubleshooting and they start concentrating more on electrical and they go solely into PCB designing, electrical circuit designing, and from there on, chip designing and integrator levels. So at the end of this course, students realize that their skills are more polished in one specific field, and they go into that specific field, whereas some people come into this robotics jumble, which is a combination of all of this together. So that is one thing that differentiates this from most of the courses.
Yeah, definitely a chance. You're right. Like, because like maybe yes, you do want to specialize, or maybe you want to specialize in like the integrated field that is the robotics itself, where you need to know a lot of like all the four fields you mentioned or earlier to like put them all together, but you don't necessarily need to be as specialized in one as somebody who just does that.
Exactly. Yeah.
Yeah. All right. Couple questions to wrap us up here, at least the list that I had prepared for
Yeah.
everything. So, obviously, a lot of educational paths out there. Why should students choose to take this specific course with us at Ashton College?
Sure. So the current course that we developed for circuits and robotics is is helping students to go to the next level in their educational career in the way that they think industry works, and in the way that they think the industry or the current environment that we are living in is going to change. The current existing, I would say, the most advanced technology that we have is kind of like voice recognition that you are using currently to help with Alexa and help with Siri and stuff like that. So the next industrial boom may be, it's called as brain machine interface, where you don't have to say it, you just think about doing something, and you have sensors that can trap your brain signals, convert it into program, and they can turn on the lights for you if you just think that you want to turn on the lights. So you understand what is going to go around with the technology, how is it going to change. So this course, through the entire process, is designed in such a way that it tells the students what is the current industry, what is the current technology, how is it advancing, and where is it going to lead them to in the future. So the students get an idea of where they're heading to, they'll get an idea of what currently is happening around them, and they'll be future ready. So because for that specific reason, these live courses are going to give them a lot of hands on. If this course is done in a normal school environment, most of the time the instructor is there right beside the student, helping them, hey, you did not connect this circuit properly, you did not create this mechanical joint properly, you wrote the program wrong over here. The instructor tends to fix the problems half of the time for the student in order to complete the session within the time duration. Whereas this course being online, it gives the student a lot of access to their own equipment, their own workspace. They'll be more convenient in their own workspace, and they'll have to do everything hands on by themselves. The instructor can only tell them what to do, but it is on up to them to get their hands dirty, get the tools, and fix and understand how it is going. It gives them more exposure, and at the same time it increases their enthusiasm to learn new things. That is the best thing I would say regarding the structure of this course that's going to help them a lot.
Okay, yeah, right on. Also, all that brain integration stuff sounds very cool. Also, sounds
It,
very scary.
it's just an example. It's just an example because that is one thing that I'm researching on. It's called as brain computer interface. That is, I would say, the next generation technology that's going to come up. And there are further more coming up. It's just, it helps students to understand how fastly we are accelerating towards this advanced future. They should be future ready. In order for you looking for a new job, you need to know what the next generation the company is going to develop in order for you to get a job in that phase, right? So I would say we'll give you a thorough idea on how things are working so that you'll be future ready.
Okay, fair enough. All right. Do you have any final thoughts or advice or something you wanted to mention real quick before we wrap up my formal list of questions here?
I don't have nothing special, but I'm very excited to start this course. I'm very excited to get some new projects. I work with different students in getting their ideas on what industrial automation, what automation do you think is gonna, save the world, help the environment, such. Very excited to do so. I'm very excited for the further projects that are coming up. Just be reminded that don't be afraid that robotics is something that is, it's vague, we don't know about it, it's going to be hard. It is a very easy course with the technology itself made learning robotics very easy, so that it is at your hands to learn, and we have a lot of resources that are available to help you throughout the entire process. We'll be there to guide you with the help of online videos, live chat, and at the we have discussion sessions to form teams to do projects and interact with each other to improve their communication skills too. So I'm really looking forward to it, and there's nothing to get tensed about. Just jump in, and then you'll realize that you did a good thing.
All right, right on. Okay, so that's everything we have planned for today. I can see for the chat that Rika was answering some questions that we got from an attendee. If you're watching this and you have any burning questions, we're opening the floor up to you now. Did we get anything from Facebook, Rika?
Hey guys, great info session so far. So we have a frequently asked question from Facebook.
Hit us.
Yeah. How many projects can we expect to build towards the end of this course?
So it is divided into three sections, where at the end of each three sections, students will develop three minor projects. And at the end, for the fourth section, everyone will put together a team, or they'll select a project individually, and they'll start designing their major project. So there are three minor projects and one major project that the student's going to do throughout this 3-month course. But as mentioned, my teaching style, every day is a project to you. Every day in every session, I'm going to give you multiple projects to learn stuff. For example, if I want you to learn about programming, I'll give you a task asking, hey, this is our project. In order for me to do home automation, now write a program to turn on a light when the sensor triggers. Now that is a project. It is not a major project, but it is a small part of a big project. So at the end of the 3 hours course, the students will do 1 to 2 small projects that they put together at the end of the week, and they'll develop a minor project. They put together these minor projects, they develop a major project. So that is how the structure is, and that is how I think it best suits this course, robotics course.
All right, very hands-on. Thank you for that. And I think that's all the questions that I have, Matthew.
Yeah, looks like Zoom is pretty quiet at the moment. Don't worry, folks, if you're tuning in and then the instant this ends, you'll have all your burning questions. I'm guilty of that too. We'll give you the contact information for you to ask, or maybe you're catching this on YouTube. Hello, future viewers. And won't be able to ask it live. It's okay. We'll still share you the contact information then. The other thing is I'm actually going to bring Rika back. Normally we have Maggie do all of our admission stuff. Unfortunately, she could not make it today. But Rika, could you give everybody the spiel?
For sure. Thanks, Matthew. Sai, I love your energy. Our students are going to be so lucky to have you as their instructor.
Thank you. Pleasure is mine.
No worries. So hello to everyone who's tuning in. My name is Rika, and I'm here to give you more info on how to register for the Circuits and Robotics course. So the next start date for the course is coming up on July 13th. It runs until September 28th. Students must devote at least 3 hours per week to attend live webinars, which are held on Tuesdays from 4 p.m. to 7 p.m. Pacific time. Registration fee for the course is 820, and students can take 10% off their registration fee for the July 13th intake. Great news. You can register at ashtoncollege.ca, or you can call our admissions officer Maggie at 604-891-1256 during business hours, or you can email ceinfo@ashtoncollege.ca anytime. Thank you.
All right, awesome. Thank you once again for doing that, Rika. Thank you once again, Sai. I'm just going to reiterate all the contact information again for everybody. I'm just going to get that pop back in front of me in the Zoom chat. All right, if you want to email Maggie a question, ceinfo@ashtoncollege.ca, letter C, letter E, info@ashtoncollege.ca, or you can call us at 604-891-1256. That is 604-891-1256. We also have a toll-free number, 1-866-759-6006. Thank you for taking the time to join us today. Sai, it's been a pleasure. Rika, thank you.